This is November 25, paper 1, section B, TZ1. And so we finished section A, and so go check out the playlist. And now we'll be moving on to question 9, section B. The function has a derivative given by this. The graph has horizontal tangents at the points where x is equal to a, x is equal to b. Okay, that means our derivative is equal to 0. Find the value of a and b. Okay, so let's do that. F prime of x is equal to 3 squared plus 12x minus 15 is equal to 0. And we just solve this quadratic equation, pull out the 3, we get x squared plus 4x minus 5. And we can do this plus 5 minus 1, so x minus 5, x plus 1. That gives us what we need, right? Yep. So that's x is equal to 5, x is equal to negative 1, and a is less than b. So a is equal to negative 1, b is equal to 5. Since a is less than b. Okay. Okay, next is following diagram shows 3 intervals along the x-axis defined by a and b. Sign of the first derivative of f is shown in each interval. State with a reason whether there is a local maximum or local minimum point at x is equal to a. So our derivative is positive, so increasing. Our graph is increasing, then decreasing. Since it's negative, so that means it's a local maximum. So let's write that down. Local max, because we have a gradient, or f prime of x, which is our gradient, is changes from increasing changes from positive to negative, which means f of x changes from increasing to decreasing, where x equals a is the turning point. And that should be sufficient. We only need one line of reasoning. And let's look at the second derivative is 0 at c. Find the value of c. So the way to do this is to use our first derivative to determine our second derivative. So that's 6x plus 12, right? We're using this. And that's 0. So x is equal to negative 12 over 6, which is negative 2. And that x is c, so c is equal to x is equal to negative 2. And so that is our answer for c. Now let's move on to D. Following diagram shows 2 intervals along the x-axis defined by c. Sign of the second derivative is shown in each interval. State with a reason whether there's a point of inflection on the graph of y is equal to f of x at x is equal to c. So since there's a change, that means we have a point of inflection. It's going from negative to positive, which means it changes concavity, right? So that means for D, yes, there is, yes, inflection point. Since or second derivative changes sign from negative to positive, which means change in concavity of F from concave down to up at x is equal to c. And we can even talk about the gradient, since similar to what we did here. We can say f prime is a gradient decreasing before, then increasing after c. And so either one of these explanations would work. Now, part E, given that f of negative 2 is equal to 36, find f of x. Okay, so we just have to do the integral, right? So integral of f prime of x is equal to our f of x. And the integral is, okay, 3x squared plus 12x minus 15 dx. So what we have is x cubed, 6x squared minus 15x plus c. Right, let's check that. 6x squared is 15x. Yes. And so let's just plug in our initial value, or initial conditions. F of negative 2 is equal to 36. So 36, so 36 is equal to negative 2 cubed plus 6 times negative 2 squared minus 15 times negative 2 plus c, and we can find out c. And so 36 minus 8 minus, plus 8 minus 4 times 6, 24 minus 24 minus 30 equal to c. c is equal to 6 plus 8, 14. 14 minus 24, 10. Negative 10. And so that's our c. Let's plug that back into our equation. So f of x is thus equal to x cubed plus 6x squared minus 15x minus 10. And that is our answer. Okay, I'll move on to question 10 next. Hopefully that helped. Please drop a like and subscribe if this was beneficial. See you guys.